Hi, my name is Captain Peter Cutsey. This is another in the series of my briefings for the 737. This one is a rejected takeoff. The captain has the sole responsibility for the decision to reject the takeoff. And making the decision in time to start the rejected takeoff maneuver by V1. If the decision is to reject the takeoff, the captain clearly announces reject, immediately starts the rejected takeoff maneuver and assumes control of the aircraft. If the first officer is making the takeoff, the first officer maintains control of the airplane until the captain makes a positive input to the controls. So that's important. And if you have a problem before 80 knots, you reject the takeoff for any of the following: activation of the master caution system, system failures, unusual noise or vibration, tire failure, abnormally slow acceleration, takeoff configuration warning, fire or fire warning, engine failure, predictive wind shear warning, if a side window opens, or if the airplane is unsafe to fly, or any other reason that the captain decides. Above 80 knots and before V1, the captain will reject the takeoff for any of the following, just 4 items: fire or fire warning, engine failure, predictive wind shear, if the airplane is unsafe or unable to fly. Now, during the takeoff, the crew member observing the non-normal situation immediately calls it out as clearly as possible. So that's just an overview, and we'll look into a few other items shortly. Let's go to the FCTM and have a look at what the Flight Crew Training Manual says. The RTO maneuver is initiated during the takeoff roll to expeditiously stop the airplane on the runway. All right. And the captain is the only person that rejects the takeoff. Okay. And it specifies if the decision to reject the takeoff, then the captain should follow, or the crew should follow, the procedure in the QRH, which we will look at shortly. For procedural consistency, disconnect the auto throttles for all rejected takeoffs. And if I was in a briefing with you, I would actually ask you a lot of these questions, but being that this is done online, it'll be very difficult. It's difficult and impossible to facilitate with you unless we had you online and I was giving you the briefing online, and we'll do that soon, especially with COVID-19. And if rejecting due to fire in windy conditions, consider positioning the airplane so the fire is on the downwind side. After an RTO, comply with brake cooling requirements before attempting a subsequent takeoff. It's very important to get that information out of the QRH performance. V1 means the maximum speed in the takeoff at which the pilot must take the first action to stop the airplane within the accelerate stop distance. And V1 also means the minimum speed in the takeoff following a failure of an engine at which the pilot can continue the takeoff and achieve the required height above the takeoff surface within the takeoff distance. When the takeoff performance in the AFM is produced, it assumes an engine failure or event 1 second before V1 to allow for reaction time. In a runway limited situation, this means the airplane reaches a 35-foot height over the end of the runway if the decision is to continue the takeoff. So within reasonable limits, if the engine failure occurs earlier than the assumed 1 second before V1, a decision to continue the takeoff will mean that the airplane is lower than 35 feet at the end of the runway, but it is still flying. For example, if the engine fails 2 seconds before V1 and the decision is made to go, the airplane will reach a height of 15 to 20 feet over the end of the runway. So when you have a chance, have a look at the FCTM, looking at a rejected takeoff with no reverse thrust. And the decision is made, as we said, at V1 to go or not to go. So if you're going to stop, you'll get stopped in a balanced field length at the end of the runway with no reverse thrust. So remember that the figures and the calculations are computed in performance not to include reverse thrust. If you had one thrust reverser, you would stop 220 feet or 65 meters short of the end of the runway if it was a balanced field length, and two reversers operating 150 feet short of the end of the runway. And effective no-speed brakes with all engines RTO, brakes only, you would actually go off the end of the runway by 430 feet. And the effective no-speed brakes, all engine RTO brakes, and two reversers, that is no speed brakes, you're going to go off the end of the runway by 120 feet. So it's very important that you follow, the crew follow the procedure exactly the way we are going to look at it here in the QRH. So this is the QRH, and we mentioned all the reasons of when we would actually do it. So it wasn't my words, it was the words out of the QRH. And here's the actual procedure, the way it's done. And I've made it a little easier in my presentation to look at it exactly what you're looking at here. And let's go and have a look at that. So the reject procedure is here. And we'll go back and we'll read it. And then we'll go into a detailed breakdown. So the captain would call reject and simultaneously close the thrust levers, disengage the auto throttles, and apply maximum manual wheel brakes, or verify the operation of RTO auto brake. So if the RTO auto brake wasn't working, the captain would apply maximum manual brake. If the auto brake is selected, monitor the system performance and apply a manual wheel brakes if the auto brake disarm light. That's just what we said. And to raise the speed brake lever, apply reverse to the maximum amount consistent with conditions, and continue max braking until certain the airplane can stop on the runway. The first officer will verify that the captain has in fact closed the thrust levers. Auto throttles disengaged. Maximum brakes applied either through the auto brake system or through manual brakes. And verify the speed brake lever is up and call speed brakes up. If speed brake lever is not up, call speed brakes not up. Reverse thrust applied. The first officer is monitoring that. And when both reversers are green, call reversers normal. If there is no reverse indications, the indications stay amber, or the indications stay amber, call no reverser engine number 1, or no reverser engine number 2, or no reversers. And very important to call out any omitted action items. Remember, you're the first officer is the pilot monitoring, but very, very much part of the operation at any time. The captain, when stopping, is assured will start the movement of the reverse levers to reach the idle dedent, which is here, before taxi speed. After the engines are at reverse idle, move the reverse thrust levers full down. And I've added a little comment here, providing the engines have spooled down. So if you don't wait, if the captain doesn't wait till the engines are spooled down when he's at idle reverse, coming out of reverse at a high RPM, which will be forward thrust, could result in running off the runway if the runway limitations, if the runway is limited as far as conditions and surfaces and whether it's a balanced field length or not. So it's very important that you understand the reverse thrust in the stowed position. The interlock is the first position after, and on rejecting the takeoff, the captain would hold light pressure on the interlock till the reversers were in place to provide reverse, then continue moving up to dedent 1, dedent 2, and then maximum reverse thrust as required. The first officer would call 60 knots, communicate the rejected decision to the control tower and the cabin according to SOPs as practical before coming to a stop, such as your aircraft ident rejected at takeoff. The reason why the first officer waits to 60 knots is he ensures that the captain has completed all his items and is coming out of reverse or all items have been done and the captain is beginning to come out of reverse before taxi speed. So at that point, the first officer has time to talk to the tower, and before the aircraft comes to a stop, onto the PA, and something like attention, crew at stations, and attention, crew at stations, whatever your SOPs dictate. It's good to repeat, in this particular case, the announcement twice. Everyone in the back is pumping adrenaline because of the sudden stop, and everyone's wondering what's going on, and your first PA may not be understood. So it's a good idea to mention it twice. When the airplane is stopped, perform the following procedures as needed. The captain will stop the airplane, and the possibility of wheel fuel plugs melting, the need to clear the runway. Don't be in a rush to get off the runway. I say that because the runway belongs to you, and there's no reason for rushing to get off the runway. You may have a problem with your brakes, as I have had in my flying career. You may have a brake fire. You may have a blown tire. So wait until someone can inspect the aircraft, and if all is well and safe, then you can actually get off the runway. And also remember that the runway is going to be inspected before it can be used by another takeoff. So there is no rush to get off the runway, especially if it was a high-speed reject. If it was a low-speed reject and brake cooling will not be required, and it was for something very minor, then that's a different story. So you have to consider the possibility of wheel fuse plugs melting, especially in a high-speed rejected takeoff. the requirement for remote parking if it was for something serious, such as uh, endangering the life of those outside the aircraft and inside. Wind direction in the case of fire, you may want to turn into wind, or the wind on the side away from the evacuation side. That's the captain's decision to make. Alerting the fire equipment. And this is another very important one, is not setting the parking brake until the passenger evacuation is needed. And Boeing put out this article a few years back, and depending on the type of brakes on your airplane, if they're steel or carbon. So if a parking brake is applied too soon after energy stop, a high energy stop, there is a chance that the rotors and stators of steel brakes can fuse or weld together. This can result in an inability to move the airplane, or unscheduled maintenance, or schedule disruption later, or disruption of airport operations. Incidentally, carbon brakes are not susceptible to this welding. So you have to know your airplane, and if you're unsure, don't set the parking brake. Set it if you anticipate an evacuation, and that would come later, and at that time, you're not interested in the fact that you're going to be moving off the runway if you're going to be evacuating. And incidentally, if you're going to have to evacuate, use the runway to evacuate. It's wider. All right, so let's go back to the main menu, and we'll just review what we have just covered in an easy way to view it. Captain is always the pilot flying on the ground. He or she would have assumed control by automatically saying reject. So the captain would call reject, simultaneously close the thrust levers, disengage the auto throttles, and apply maximum manual wheel brakes or verify the operation of RTO auto brake. If RTO auto brake is selected, monitor system performance and apply manual wheel brakes if the auto brake disarm light illuminates or deceleration is not adequate. That's important because the auto brakes on the 737 will give you the maximum possible braking, more than manual braking. Raise the speed brake lever. The first officer will verify thrust levers closed, auto throttles disengaged, maximum brake supply either through the RTO system or through manual system. Verify speed brake lever up and call speed brakes up. If speed brake lever is not up, call speed brakes not up. The captain will apply reverse to the maximum amount consistent with conditions. Maybe he won't have to apply maximum reverse, depending on what speed it happened. Continue maximum braking until certain that the airplane can stop on the runway. First officer's duties as pilot monitoring will verify that the reverse thrust is applied, and when both reversers are green, call reversers normal. If there's no reverse indication or indications, or the indications stay amber, call no reverser engine number 1, or no reverser engine number 2, or no reversers. And also monitoring the captain, making sure that you call out any omitted actions, items. And then the first officer will call at 60 knots and communicate the reject decision to the control tower and cabin as soon as practical. When stopping is assured, the captain will start the movement of the reverse levers to reach idle dedent before taxi speed. So normally around 60 knots, the captain will start coming out of reverse and be in the forward idle position at taxi speeds, around 45 knots roughly. And after the engines are at reverse idle, to move the reverse thrust levers full down, providing the engines have spool down. So when in reverse idle, do not move the thrust levers to full down until the engines have spool down. Otherwise, the high RPM will be forward thrust and will perhaps take you off the end of a runway if runway is a restriction, or if the runway is slippery. So very important to wait for the engines to spool down before you go to forward idle. First officer, in the meantime, will monitor the captain to ensure that all the items are completed. When stopped, consider not setting the parking brakes immediately after, that is, after you stop, for the reasons I just mentioned, in case you have steel brakes. In any case, you would follow your company SOPs. If you have to evacuate, then you would part of the evacuation checklist, which is a red item from a checklist. The first item is parking brake set. Stow the speed brake lever and advise passengers on the PA to remain seated with seat belts fastened, or in whatever language your SOPs dictate. The first officer to monitor the captain to ensure that all items are completed. So that's a good review and a very important procedure that you'll be carrying out in the simulator. And I hope you enjoyed this briefing, and we'll see you at the next briefing. Thank you.